Hello class, we are going to look at section 2.5 here. We're going to learn a couple of properties that we can use in algebra. We use them for a few reasons. One main reason is to perform some mental computations. So we don't always have to pull out our calculator for stuff that is simpler than we think. We have two learning targets today. First, we want to state and apply the commutative, the associative, and the distributive properties. One thing I want to point out right away is there's no N in commutative. Alright, a lot of people call it the commutative. It's not, it's the commutative. We're then going to use those properties to perform mental computations. So, let's start with that commutative property. Now, what the commutative property tells me is it doesn't matter which order I add in, okay? So I could say, like, for instance, 2 plus 3 is equal to 3 plus 2. Because 2 plus 3 is 5. And 3 plus 2 is 5, all right? So, addition is commutative. This also holds true for multiplication. 2 times 3 is equal to 3 times 2, because 2 times 3 is 6, 3 times 2 is 6. Now, that being said, this property holds true for addition, but it does not hold true for subtraction. 2 minus 3 is not equal to 3 minus 2. Same thing with the multiplication. It holds true for multiplication, but it does not hold true for division. With division, 2 times 3 is not equal to, 2 divided by 3 is not equal to 3 divided by 2. So this commutative property only works for addition and multiplication. The next property is called the associative property. This one helps us kind of change the order we're adding or subtracting. Alright, so if we have 1 plus 2 plus 3, what they're telling me is that's equal to 1 plus 2 plus 3. Alright, so we can group it a little bit differently. Here we'll get 3 plus 3 using our order of operations. Here we get 1 plus 5, and again, those end up equaling the same thing. Alright, so it helps us group things differently. It also holds true for multiplication. We can group up our multiplication a tad differently as well. The next property I want to show you is called the distributive property. Now, this is probably the one you will use the most. Hopefully I'll remember how to cut out this portion. There we go. The distributive property. Now, the main thing I need you to know for the distributive property is that when we have something like this, some number times b plus c, so some number times a grouping like this, that a needs to be distributed to every single term. Now to illustrate this, let's use food, because everybody loves food, right? So we have some combo meals here. Now let's say I wanted to buy everybody in your class a combo meal number 1. We'll keep it simple. A combo meal number 1. Alright? Now, a combo meal number 1 consists of 1 burger. It consists of 2 fries. I don't know why it has 2 fries. Alright, it's just an example. And it consists of 1 McCafe. Alright? And like I said, I want to buy it for everybody in your class, so I'm going to have to buy like 20 of these. Now, let's say I made the mistake that's very common, and what I did is I only distributed this 20 to the first term. Okay? So I multiply and I say, oh, that's equal to 20 burgers, 2 fries, and 1 McCafe. Alright, because many students only multiply by that first number. Well, if I were to bring this amount of food to school, when I told you I was going to get you all McDonald's, there'd be a lot of people upset that they didn't get their fries, that they didn't get their McCafes. So instead what we need to do is we need to distribute that 20 to every single term. All right? So if I wanted to buy everybody a combo meal number 1, I would need to get 20 burgers, 40 fries, and 20 McCafes. The point is this. When we use the distributive property, we must distribute this to every single term. Now, why is that useful? Well, like I said, we'll be using distributive properties in many different ways throughout the year. One way it's really shown how useful it is in this section is by the following. Doing some mental computation. So let's say we want to do 5 times 32. So I say, hey class, what's 5 times 32? A lot of people would probably pull out their calculators. Here's what I'm going to show you. That's not necessary. Let's make this a little simpler. Instead of saying 5 times 32, I'm going to change this into 5 times 30 plus 2. Right? Because 30 plus 2 is 32. All right? But what we can use here is we can now distribute. We can say, all right, 5 times 30 and 5 times 2. So I get 5 times 30 is 150, plus 5 times 2 is 10. So 5 times 32 is 160. All right, so we can do this problem using mental computation. Another example of this, 4 times 93. Now you may be thinking to yourself, well, Mr. Lynch, 4 times 90 isn't necessarily all that easy. Well, how about we do this instead? Let's do 4 times 100 minus 7. Because 100 minus 7 is 93. And when we go to distribute this, we do 4 times 100 and 4 times 7. So we get 4 times 93 is equal to 400 minus 28, or 372. So there's many times up here in front of the class that we're going to have like this sort of operation happen, and I'm going to do it in my head, and I'm going to try to pretend like I'm really smart and I can just do that in my head really fast. But the secret is I'm just doing the distributive property. I'm doing something that looks like this. All right, I may be doing it in my head, but that's our goal. We want to be able to do this mentally. We don't always want to have to pull out a calculator. And if we break it up into operations that are easier, such as 5 times 30, that's 150. 5 times 2, that's 10. And then just add them together, we'll be able to do this mentally. And we could look at something that's a little bit more difficult even. How about this? Now, you'll notice that this is a problem from your homework. You're welcome. Okay? This is a problem taken directly from your homework, so I'll do it for you. Hopefully you made it this far into the video. A lot of people just say they watched the video and don't actually watch it. So if you actually watched it, here you go. You're welcome. I'm doing one of your homework problems for you. If you see someone who didn't actually watch it, don't tell them that this is in there. All right? This will be our little secret. So, 5 times 91 times 2. Let's change this up a little bit. Instead of writing 5 times 91 times 2, I think I'd rather write 5 times 2 times 91. I'm just going to change the order. Now, if you remember, that was the commutative property. The commutative property lets us switch the order like that. In this second step, what we're going to do is we're going to group things just a little bit differently. All right? Instead of having the 2 times 91 grouped, let's instead group the 5 times 2. And then we'll multiply by 91. If you remember, that was the associative property. Now, you may be wondering, Mr. Lynch, why did I group the 5 times 2? Well, the reason I grouped the 5 times 2 is because 5 times 2 is simply 10. And it's a lot easier to multiply things by 10 than it is to multiply by other numbers. Because we all know 10 times 91 is just simply 910. So we can do these kind of things mentally if we know how to change the order. Right? If we know the properties of being able to change the order and group things differently. It takes practice. It definitely takes practice, but you'll be able to do this soon as well, assuming you actually do the practice. So that's how we use the commutative property, the associative property, and the distributive property. Well, one of the ways we use it anyway. A couple more properties to know. This is really mostly for vocabulary at this point. The reflexive property tells us that a number is equal to itself. The symmetric property tells us that if A is equal to B, then B is equal to A. The transitive property, if A is equal to B and B is equal to C, then A must be equal to C. And last, the substitution property. If A is equal to B, then we can substitute B in for A, or A in for B, either way. This will be very useful when we get to chapter 7. If you look ahead, there's actually a section in chapter 7 called the substitution method where we do exactly this. So, in summary, here's the properties we looked at today. We also involved the inverse property here, which we'll talk about more in the next section. So, get your homework done. Thanks.